Okay, now let's look at the second test we can perform in the lab, which is a tracking test. Okay, so this is the setup or the arrangement for performing tracking tests. Right, so same thing, we have the electric material as sample to be tested. All right, place here. All right, and then same thing, we will have HV transformer to supply the HV AC. Okay, you can see here connected to the top of the sample. Right, then at the bottom of the sample is connected to the ground. That is basically the main arrangement. We have the insulation. We want to test the insulation, so we have to supply high voltage and ground. Okay, one side we connect it to high voltage, the other side we connect it to the ground. Okay, and then the rest is just additional. For example, of course we need to measure the leakage current, we need to measure the voltage, and then we have to include the resistor to limit the current for safety. And also we have to additional, we put over current relay if there is somehow the current shoots up. Okay, that it will stop the system. And then also we have thermal camera to observe that tracking. Okay, tracking on the surface of the insulation. And then we have water to drop to supply water droplet on the surface of the insulation. All right, so we have another picture of the tracking test, much simpler. Okay, you can see here we have supply, and then the supply connected to the electrode, which is connected to the top of the sample, and then the bottom of the sample is connected to the ground. Right, and of course we need to have the test solution, or the water that is being dropped, okay, on the surface of the insulation. Okay, surface of the sample. And then we put the resistance to limit the current. Okay, that is basically the concept here. So you can see here, this is the insulation sample. This is the insulation sample. This is um, the electrode connected to the high voltage, and this is also, we have water droplet. Okay, water being supplied on to the surface of the insulation material. All right, so this is example of the test. The specimen, the dimension of the test, dimension of the test sample. So the voltage supply 2.5 kV, 3.5, 4.5, and so on. And then the test solution, the water is supplied at 0.15 milliliter per minute. And then failure criteria method. So if the current exceeds 60 milliamp, or the specimens burn, or hole is formed on the surface, then the insulation failed. Okay, so this is the idea, to check whether the insulation has failed or not, failed or passed the test. All right, same thing. Okay, let's just quickly look at the summary. So this method can be used to assess the susceptibility to tracking of insulating materials that are exposed to high voltage outdoors. Okay, so we want to check on the insulation, because the insulation is exposed outside, exposed to the rains. So during rains, can it withstand that high voltage? Insulators installed in the open area are often at the mercy of humidity, a lot of humidity outside, so their electrical insulation properties can deteriorate to such an extent as a result the tracking paths are formed on the insulated surface. So basically, because of the humidity, because of the rain, and then you can see that over time there's a tracking on on the surface of the insulation material, the tracking. um, so that is basically can result to flashover or full breakdown of the material. Okay, so the test determines the tracking resistance that defines the dielectric strength of the insulating material surface and the maximum allowable leakage current, right? So this is the setup. Transformer, for example, 415 step up to 11 kV was used to supply the power to the test circuit, and its output voltage was measured using high voltage probe. Okay, of course we need to measure the output to monitor if we are injecting 2.5, 3.5, 4.5, right? Each sample was fed from this supply via a high voltage relay and resistor. So we have resistors, a relay connected to the sample, right? Um, the resistance value is depend on the test voltage and the flow rate of the contaminant. So basically have to adjust the value of the resistance. Oh, sorry, this resistance value is dependent on the test voltage and the flow rate of the contaminant. So it's basically um, suppose resistance um, of the sample, right? The test is conducted. The test is conducted could last up to 6 hours. Okay, depending on the test method. Basically, we have to look at the standards. Okay, the standards. What is the standards requirement? If it can withstand up within 6 hours, there's no problem. There's no flashover. There's no hole. Okay, then the leakage current less than 60 milliamp, then it failed the test. Sorry, it passed the test. Okay, so we have to check on the test method. We have to check on the standard, right? ASTM and so on. um, the circuit may also have additional protection scheme in place in case of emergency, so such as overcurrent relay, and so on, right? The current flowing across the sample is measured using a resistive shunt. So we have where is it here? There is no resistive shunt here, but basically we will need to measure the current, okay, to check on the leakage current. And then the peristaltic pump was used to create a water flow. Okay, so we have this unique pump so that we can control a specific amount of water for a period of time, for example, so that we can control 0.15 milliliter per minute or 0.30 milliliter per minute. So we need this um, specific flow rate of water. Alright, so the current and voltage are monitored using LabVIEW. It doesn't have to be LabVIEW. Any software to monitor the current and voltage is sufficient. Okay, as long as we can monitor the current and the voltage, that is good enough. um, An optional measurement device such as video or thermal camera can be used to provide visual data. Okay, because the process will take, for example, 6 hours, so you will need the camera to assist you in observing the process of the tracking, right?